I'm Tom Ferline. I'm the Director of the Center for Computational Research, and we have 3 other people in the room. I'll let them introduce themselves, and then we can get started.
I'm Bob DeLeon, the XMS Project Manager.
I'm Steve Gallo. I'm a software engineer responsible for the back end of the XDMOD user portal.
I'm Matt Jones. I'm the Technical Project Manager.
So I thought I'd give an overview of XDMOD, what we're doing. We've added some new feature to it that I think you may be interested in, and we'd be happy to follow this up with anybody that's interested with an actual hands-on demo, because this will all just be PowerPoint slides, but you can learn more with a demo where we're actually, in the interface itself and doing different things, creating plots and those sorts of things. So that offer's out there, but I thought I'd just go through my slides for you. Those of you that are can't see the screen or going to go thumb through the slides on your own, I'm at the overview slide, and I'm going to now move down to the outline. So I'll talk a little bit about the motivation, then the portal itself, just a brief introduction, show you some of its features, and then the 2 things that I'll focus the most attention on are, 1, how we use it to measure the quality of service of high-performance computing infrastructure. And then lastly, the thing that we're going to be releasing at SC15 is, with this software, you can actually measure the performance of every single job that's running on a given cluster, whether it's an XSeed resource or whether you're running it at your home institution. And there will be an automated process to identify poorly performing codes, and then you can work with those users to improve their performance. I'm going to the next slide, which says Comprehensive HPC Management slide. So anyway, XDMOD, this started more than 5 years ago now. We just started our renewal in July of this year, so we're entering our 6th year. It's a grant it's been changed. It was called Technology Audit Service, so you're probably used to TAS. In the renewal, it's called XDNet Metric Service. And the reason they chose XDNet is they wanted to distinguish it from being XSeed only. It applies to the service providers, it applies to other systems in the portfolio NSF management. So that's why they were sentenced to use the word XDNet as opposed to XSeeds, and then metric service. At the end of the day, it's a metric service. So there's 2 flavors of XDMOD. There's the version that runs on the XSeed resources, which you can log into. It has a public role, and it also has other roles which you need a password to get into. And that's looking at all of XSeed's resources. And then there's an open source version called OpenXDMOD, which we run here at our center, which is probably installed at, 150 or more HPC centers worldwide. So some are academic, some are industrial. So anyway, but the bottom line is they're both pretty much, they share the same feature sets. One works on XSeed level data, the other works on your center's data. And it's an on-demand responsive portal that lets you look at usage, performance, those sorts of metrics. I'll talk about them in a little bit in a minute. It supports several different resource managers: Slurm, PBS, LSF, SGE, so pretty much all the major ones. And then you can, as I mentioned before, you can measure quality of service. HPC systems, as you all know, are complex combinations of network, storage, processors, and you never know they're actually all working. We hope they are working efficiently, and so we run these things called application kernels that I'll mention they run periodically every day, every other day, and they look for consistency. And when something's not consistent, you try to figure out why it isn't consistent. I'll talk about that. And then the most recent thing is we call it Supreme. Don't ask me what it stands for, but it's job level performance data for every single job running on the cluster. And the nice thing about that is you don't need to recompile the jobs. We simply look at the hardware registers on the nodes and pull the data off from there. So it's unintrusive. And as I mentioned before, there's OpenXDMOD. I'm going to go to the next slide. So 2 motivation slides. This one, we want to improve the user experience. So we like to say the user shouldn't be the canary in the coal mine identifying problems. If you look at the plot you see there, it looks at each one of our 1,000 nodes. This is at our center, so that's along the x-axis. And along the y-axis is the size of the system log file that's produced when a job runs. So most of the time the log file is tiny because the job runs to completion. You get a very small log file. But on two of the nodes, one is 120, and we ran this at our center, and you can see it was back in 2011, but it's a good one, so I use it all the time. One of the nodes had a very large system log file. It's easy to identify, and that was node 126, and it turns out it was a job scheduler error, so you just have to reinstall the OS and the job scheduler, and you're good to go. But the interesting one is 348. It turned out it was a sporadic error. Every so often, it had a loose cable, so every so often jobs would fail. And those are the type of things you would never identify because some poor user would get that node in the bunch of nodes that he asked for, and then the job would fail or hang or whatever, and they're not going to try to figure it out, and we don't, as system support personnel, we don't always have the time to do that, and so they would just resubmit the job, and then some other poor person would get node 348. So anyway, just by looking at the size of the system log file, which is available to everybody, you can identify problems. And then secondly, so that's what we call a quality of service issue. But then secondly, and I'm going to talk about that as a supreme project, we want to look at the efficiency of the codes that are running on the clusters. I can speak to our own center here. We have thousands of jobs run every day. We don't know what the users are doing, and most centers, I'm sure pretty much all centers don't know that. One example was we had a user who used a source code from a previous postdoc or graduate student who got it from a previous student, and they were requesting 40 nodes. Each node has, 12 or 20 or 16 cores, and the code was sequential, so it was running on one core out of 40 nodes, and all the rest were sitting there idle while that job was running. So if you look at the plots you see here, here's an example on the left-hand plot. It's a plot of CPU user, so you want to see it running at 100% efficiency for it looks like it's about 7 nodes. But if you can read the y-axis there, for the entire time the job is running on 7 nodes, it's running at most at 30% CPU efficiency. We contacted the user, we looked at what they were doing, and then on the right is what happened after we worked with them. So here they were only running on 4 nodes, but the processors were running flat out at 100% efficiency. So that's the motivation into the software that we've developed and we're continuing to develop to try to, one, make sure the systems are running efficiently, and then two, make sure the users are running as efficiently as they can. I switch to the next slide, and I'll just go over the portal in a detail. Like I said, we are happy to offer a online WebEx type demo where we actually go through all the options. We do it in real time, and if you have an account, you can log in and follow along with us. So the portal, I hope most of you are familiar, some of you are familiar with the XDMOD portal. It's a GUI interface, and if you look at that plot, you've got a bunch of tabs. There's a usage tab, a metric explorer tab is the tab we're showing there. And it's very easy. You can just say, I want to add data. What kind of data do you want to add? Do you want to add jobs data? We divide the data up into things called realms. So it can be jobs data, which is just how many jobs were run, who's running on the machine, what departments are using it, what field of science. Or we can look at performance data, which I mentioned before. We can look at the allocations. And so you can easily plot data for a given range. If you look at the top there, you see the duration. It happened to be defaulted 90 days. You can choose previous quarter, previous year. Those are defaults. You can choose the start and end date if you want specific ones. You can then, if you look to the right a little bit, you see something called export. You can take whatever plot you produce and generate is it a TIFF or JPEG or I forget what it is. But anyway, something you can export. You can export the data as a spreadsheet. You can click the little button that says make it available for report, and then if you look along the top where the tabs are, you have allocations, app kernels, apps kernel support, and you have a report generator tab. And you might not always want to go into this interface every single week or every quarter and regenerate your plots. So this allows you to say, okay, I'm going to do this once, like as a center director, I have a series of plots I always want to see every quarter or every week or every month. I can generate them once, put them in the report generator and tell me, hey, email that to me as a PDF file every whatever the period you'd like. So while the interface is nice, you don't always want to be regenerating the plots, so we offer you the ability to get in there. And you can also, in the future, generate the plots for somebody else. So you can say, okay, well, I know the provost at our university who want to see this particular information. I'll make a standard report for him or her, and then I will make sure it's emailed to them. It's done automatically every quarter. Next slide. These are just some plots. I'm looking at CPU hours delivered by Decanal units. So this is for our university. Not surprisingly, you can view this as a bar chart, a pie chart, or whatever you like, but not surprisingly, engineering and the natural sciences are the two heaviest users in terms of CPU hours. If you were to look at storage, it would be a little bit different story. There you'd see the life sciences have a higher amount of permanent storage space. So anyway, this plot took all of probably 10 seconds to generate, and then as I mentioned before, you can export it. The next slide just shows you some of the drill down capability. So if you go back to the previous thing, you see this pie chart. I could have clicked on the School of Sciences and Applied Engineering, School of Engineering and Applied Sciences, and said I want to look at that information over the departments, and then I would have gotten the various departments that you see there, their CPU utilization and number of jobs for whatever the given time period was. So again, simply by clicking on the College of School of Engineering and Applied Sciences, I would have gotten all the departments, and then if I want to know, hey, within that department, civil engineering, who the heck is using it? I can just click on that with the pointer and say drill down, and drill down by faculty member or PI. So it's a pretty powerful and easy to use interface, and we've tried, it's got a lot of features, so that makes it's a challenge because you want it to be able to do a lot and be flexible, but then that always adds complexity because you want it to do a lot too. So that's why I really recommend, if you're going to get seriously, and there's a lot of features in there that I don't know about, I learned by watching our staff here do things, so we are happy to do a WebEx. I'm going to go to the next slide, talk briefly about quality of service, and that's the application kernels. So we run these, they're really snippets of code, and we run them periodically. Most of them run every day. They run for no more than 10 minutes. They run on two nodes, is it nodes or cores we do these days?
That's match, string, use all the cores on the nodes.
Okay, so we use all the cores on the nodes. Okay, so we'll run on, in parallel, we'll run on multiple nodes and using all the cores on the nodes. And the idea is not to be too computationally intrusive. After all, you don't want to chew up a lot of valuable cycles that other users could, but you also want to run them daily because you want to be able to look at the performance of various things like the file system, the various application codes, and make sure that they're actually running efficiently and there's not an issue with them. And let me show you what I mean by that. So we measure things like local scratch, global file system performance, processor speed, network latency, and bandwidth. And I'll give you two examples. There's actually several more that we could show you. Go to the next slide and we look at a use case. This is the popular code NWChem. I'm a computational chemist, so I'm familiar with it. We are running it here at our center, and if you look at the x-axis, that's the time, so May, June, June. And then if you look at the y-axis, that's the amount of time the code takes to run for 8 cores and 16 cores. And so if you look at that, I suspect you think the time on 8 cores is pretty much flat, which is what you'd like to see because you're running the exact same job every single day, and the execution time should be consistent. Well, at our center, we noticed on 16 cores, the execution time was hardly consistent. Sometimes it would run more quickly than the job on 8 cores, which is actually good, right? But most of the time it didn't. And so it turned out when we investigated this, there was a bug in the parallel file system, Panasis. When NWChem went to check to see if the file system was available to write on, there was a bug, and sometimes it wouldn't return, or would return much later. And so this was a bug that was in the commercial version that we were running. We worked with Panasis. We told them what the problem we found, and then they sent out a patch to their commercial parallel file system. My point in all this is not whether Panasis is good or not. We had good experience with it, but that these types of things happen all the time. So some poor user would submit an NWChem job. It might run efficiently. Other times it might not. They'll just say, oh, I don't know why it failed, so I'm just going to resubmit it. And think of all the wasted CPU cycles then that would occur, or it would take way longer to occur. Nix had a similar case where they they upgraded to a new version of NWChem, and it actually ran slower, and it actually ran slower on multiple cores than it did on a single core, and it was because it was missing they linked to old libraries or something along those lines, and they weren't aware of it, and we made them aware of it. It had been out in production for a couple of months. So anyway, these types of things, they're complicated systems, and you want to ensure that they're running efficiently. And here's the second one. If you go to the next one, this was a file system performance issue.
Oh, before we go on, there's a question on the chat. Jaime, I believe, where does it take the information for groups, subgroups, and assign users to groups?
I'm not sure I understand the question.
Yeah, if you ask the question, can you clarify, or feel free to jump on the phone?
Wait a minute. So the question is, so you show that plot when you click on the plot and you go to engineering, and then you click on the plot and you go to civil engineering.
Oh, yeah, that's a good question. So how do you determine the hierarchy of your institution?
Yes.
Is that your question?
Yes.
Okay, we have Steve. You want to answer that, because I'll probably goof it up.
If you're running this on a non-exceed center, you can provide CSV files that we parse that map users into departments, and then also departments into Decanal units. And we're working on a little bit better way to do this in your REST service, where we can have unlimited number of levels in the hierarchy.
Did that answer your question?
Yes, thank you.
Yeah, that's a good question, because not every organization is like the University of Buffalo's highly efficiently administered organization, so you might have your own organization. So, and we're working on streamlining that. It is up and running. We don't know everybody that's running OpenXDMOD. We only see when they ask for help, and so we figure it's somewhere in the neighborhood of 150, maybe 200. And so we have a CCR help, and if you have issues, we have somebody that does that, works on that every day. So I'm going to go back, and if there's no other questions, I'll go back to the application kernel use case, which is the one, the file system performance. And so we do an MPIO collective N-to-1 write throughput test. And so if you look before January 6th, everything was going well. On 8 nodes, the file system performs better than it does on 4 nodes. And on January 6th, on our parallel file system, it fell off the end of the earth. And the beauty about running these application kernels every day, or pretty close to every day, is we said, well, what happened on January 6th that would cause this to happen? We went back to the logs and found out that we upgraded the firmware, was it, on the network switch?
Oh, it was our major maintenance downtime, so we actually upgraded far too many things, which made it a lot harder to unravel which particular one had caused this issue.
So like most centers, we were down, and we upgraded more than we probably should have. But anyway, we knew January 6th was when we did that, and so that led us to start some detective work. It turned out that the problem was with the firmware upgrade, but before we could actually identify it as a firmware upgrade, I think we had to update the parallel file system, and you have to wait a month to bring that down, so there was some detective work. But after a fair amount of detective work, we were able to resolve the thing and bring the file system back to its performance. Again, these are the types of things, unless some user was using that and noticed that, and we had one user, I think, that was really a heavy parallel I/O user, and I think he noticed.
And he was the only one who complained.
And he was the only one who complained, but you would have had a system that was underperforming. Same way with TAC, and I'm not picking on TAC because they're very good. This was our center, but TAC also did an upgrade to their file system, and through our application kernels, we pointed out that the performance was actually not as good as prior to the upgrade, and then they figured out what had went wrong and restored it to its optimal performance. So that's my story on application kernels, and now I'm going to turn to measuring job level performance. So if you're running OpenXDMOD, first of all, the job level performance data is available in XSEED. For the XSEED resources, I'll try to get them all. It's on all the TAC resources because it's using software developed at TAC. It's on San Diego's supercomputing Gordon and Comet. It will be on the Pittsburgh Bridges when it comes up. It's on LSU's SuperMike. And am I missing anybody?
I don't think so. I think it's
So pretty much Pittsburgh's the only outlier, and they felt that they were going to wait till Bridges to come up. And so when Bridges comes up, it'll be available. So it's a realm within the XDMOD interface that you can look at this performance data. But anyway, so it's a collaboration with TAC. It's the integration of XDMOD with monitoring frameworks. So we're agnostic. The XSEED uses TAC stats and Lariat. Lariat captures the application data. But we also work here with Performance Copilot, which was an SGI product many, many years ago, but now is actively developed, and is it maintained by Red Hat? Are they
the major developers are employed by Red Hat.
Yeah, and it's going to be part of the Red Hat release. So we've done a lot with that, and we'll probably use it as our monitoring framework here, but Ganglia, those sorts of things. So there's tie-ins for all that. And what it does is it supplies XDMOD with job performance data. So what applications were run, how much memory was used, I'll go over that later. Local I/O, those sorts of things. And the way it works, if you look at that little flow chart, is we record from the hardware counters on the nodes for every single job. We record, how much CPU they used, how much memory, what was the I/O bandwidth. We then aggregate that data because you're collecting it off the nodes, and you have to associate it with a given job that was running. So we do it per node and per job. We then push all that data into a XDMOD data warehouse, and then it becomes searchable, and you can generate reports. I'm going to go to the next slide.
Excuse me, Tom.
Yeah.
Just real quickly, TAC is covered. Does that include Lone Star, which is TAC but not XSEED? Do you know?
It's running on Lone Star, that I know. TAC.
Oh, okay. Thank you.
And so, as Matt would say, the metrics gathered per node, anything available is really CPU, I/O, memory, file system. It's extensible. Measurable quantities can be included in some development work, CUDA, mics, Panasys, GPFS. And the nice thing about it is so far we've not been able to measure overhead that it requires in terms of what does it cost you to run it. On the XSEED system, it runs every 10 minutes. It pulls data from the hardware counters. We've actually run it here, pulling data every, 30 seconds. Every 30 seconds, and I don't think we noticed much of a performance degradation at all, if any. So anyway, the beauty of it is that the users don't need to recompile codes. We can see what they're doing without them compiling their code, so we can watch what their performance level is, and I'm going to give you some examples of why that's been important. Next slide. Why we collect job level performance data. I think I've already. We're interested in creating a user report card where basically for a given user we'll say, hey, here's what your efficiency was in terms of CPU idle, in terms of other metrics which are important, file I/O, and those sorts of things. And oh, by the way, here were your top 20 applications. Here's all the people that were working underneath you, and oh, and by the way, here's how you compare to the averages for that particular HPC system. But then, and we're using it here, we can identify underperforming user codes, and it's an eye-opener, to be honest with you. Some are really easy. People are running codes that think are parallel, and they're not really parallel, or doing things that you normally shouldn't be doing. But it has to be automated. So we run thousands of jobs per day here, and it's not possible to manually search them. So, and what we can do is we can flag jobs for whatever metrics we think are important. So are there idle nodes? Is there node failure? Are there high cycles per instructions? And once we choose those, we can then have those jobs kicked out, and our HPC support specialists can take a detailed dive on them through our interface, through something we call the job viewer, and be able to look at what was going on and see if that's something that's readily fixable, and then work with the end user to do that. I won't go in. We can do this in real time. It's better to see, but there's a tab, if you look at the top right, I switched to the next one, the Job Viewer tab, and I have circulated a tab called Job Viewer. That's new. That was just released at XSEED 15. And you can actually enter a job ID, that's the leftmost circle, and once you enter that in, it brings up a lot of information about that particular job. Here we're just looking at, overview information, who ran it, where did it run, how long did it take to run. But if you go to the next slide, you can obtain detailed statistics on it. So if I just look at somewhere halfway down the thing, there's 3/4 of the way down, you see in the main panel there's CPU idle. And we give you the average the minimum, the maximum, the median, standard deviation. So we kind of give you the high water marks, and then, and so you can see it for this particular job, the CPU was idle 29, I assume that's a percent, 29% of the time, which isn't super great. And then you can actually, sometimes we see idle times as high as 90%, which isn't good. And you can say, well, maybe the user will tell you, well, I was doing a lot of I/O. Well, you can actually go look and see if they were actually doing a lot of I/O. And like I said, in many cases we found that it's just a poorly performing code. And then the next one, you can actually get detailed time series plots. And again, a lot of this stuff is better to show you in a demo, but you can look at, the CPU efficiency over time. And we've actually seen cases where the CPU efficiency, actually I have an example of that, is going great guns and then all of a sudden falls off the face of the earth, and there's reasons for that. The other thing I'll point out is, Matt here did some digging on the Stampede systems and found use cases where basically people were used to Lone Star, which had, I think, 12 cores per node, and they were just taking their Lone Star script and submitting it to Stampede, and the end result of that was there were 4 nodes, because Stampede has 16 cores per node, so 4 of those cores were going idle, and it was just because the users didn't know better. They didn't know that you need to change that parameter in your script. So those are the types of things that are really easy to identify and easy to correct, and yet they're valuable. They free up resources for the oversubscribed resources. Next slide.
Before you go on, we have a question from Roger Moy. Are all the features just mentioned available on the Open XDMOD version?
Steve Gallo, our lead software engineer, is here, and I'm glad you're asking that question. They soon will be. We plan to have the beta, the application kernels, yes. The only thing that I'm showing you that's not is everything to do with the job viewer, the job performance level data. We are running it here. We're running it successfully on the open source version. At supercomputing, which is not too far away, we will release it as a beta release to everybody. And then we will ask for your feedback to, be patient. But anyway, we intend to release the job viewer, job performance level thing as a beta release to everybody at SC, or just before SC.
The Supreme data itself is not available either.
Yeah. So did that answer your question? Okay.
Yes.
Okay.
Excuse me. The chat button is not working for me. I just have a question.
Okay.
Is the average CPU utilization for the different XSeed machines available? Because that would be very interesting.
If you log on using your XSeed credentials, you should be able to see that.
It's in the Supreme realm. Again, we'd be happy if you want to just bounce me an email, and then we'll set up a WebEx or another phone conference to do it in real time while you're sitting there.
The short answer is yes.
If you want, also, if there's time at the end, we can do a demo here as well.
Okay.
Yeah, Tom, this is Nancy Wilkins-Deere. One of the things we're thinking about in ECSS is when we have some downtime for folks who aren't assigned to projects, is trying to go out and proactively look at some of these poor performing codes and then talk to users individually. So I'll talk to you about that at some point.
Yeah, and I think I mentioned this at the last quarterly meeting, but Nancy, we have somebody here who actually worked at Pittsburgh, but he's training himself in this job viewer and job performance, and we're happy to send him out. Part of his job is to send him out to various institutions, XSeed, but it could be any of an academic high-performance computing center, and to sit down with the support specialist and take them through it and show them how to use it and how to drill down and do all those things. So that offers a standing offer anytime, and we'd be happy to do that.
Great. Thanks a lot, Tom.
Okay. So I'm just going to, at the end, I'm getting close to the end, I'm going to just go through some success stories, and I'm going to give all the credit to the first slide, maybe all the slides, I don't know. I don't remember what I have here. But this is all stuff that TAC did and found out. So they had milk code, which is a quantum chromodynamics code, is that? And one user, they looked at just the cycles per instruction. It was higher than average for that particular code. And so they found out that they weren't using, I'm not sure what available vectorized intrinsics were, but they found out that they would improve that user's runtime by 11%. So a 10% reduction in runtime is nothing to be sneezed at. And then there was a turbulence code, and again, I think it was Todd Evans at TAC ended up with an overall improvement of 7% just by doing some simple things that didn't require that much effort, but that a user might not know. And then my favorite one, though, is a singularity code. It's general relativity. At TAC, in the first quarter of 2014, I think it was the third most heavily utilized code. So it was 239,000 SUs consumed. That was not compiled with optimized turned on, and it was making whatever the extraneous calls were, but Todd worked with them, and he achieved a 26% reduction by making those relatively simple changes. And again, this is for a code that was their third most heavily utilized code for a given quarter in 2014. So think about all those cycles that would get freed up. And then here's another case where these are easy ones to fix because the users, that big yellow line along the bottom is our 6 nodes. The one thin line along the top is one of the nodes is running flat out doing all the work, and like life, some people do a lot of work and the others just sit back and watch, and the other 6 nodes were just happily doing nothing. And so again, there you're trying to recover some wasted CPU cycles. And then this is an interesting one. So this is again Stampede, and here's a case. It's hard to read that, but if you look at the 2 plots, one was before and the other was after. On 45 nodes, this code was running flat out at almost 100% efficiency. That's great. It got to the very end, and for 3 hours, 45 nodes just sat there, and they were not doing anything because they were collecting all the data at the end. And Todd worked with them and said, you know what, you could actually do a parallel write, and instead of spending 3 hours doing that, spend a few minutes doing it. So what it's the end result? You return 45 nodes back to the end user for 3 hours that were basically wasted hours. One other example I'll give you from here, and I don't have a slide for that. We have a user in biology. He has graduate students, and we've kind of told them numerous times that your job is not parallel. You need to only request one core because we allow users to share nodes, unlike XSEED. And so they nod their heads and they say, oh yeah, I'll make sure next time I do that. And then they submit the scripts, thousands of jobs, and they're asking for 8 cores, and then their jobs happily use only one of those cores. And so in 1 month alone, in March of, I think it was this year, out of 179,000 CPU hours they consumed, the CPUs was idle for 160,000 CPU hours. Wow. So we found out it's not enough to tell the students, so we told their advisor, and now we're going to watch it. And if it happens again, then we will just drop their queue priority to be punitive until they figure out that they're going to, make it run more efficiently. So anyway, these things happen. Our users are no different than anybody else's users, and many times it's unintentional. Once they know better, they do it. And so anyway, this last one is just kind of how things work. It's a flow chart. You take all the jobs running on the cluster, you run Supreme, XDMOD, you collect, prologue, epilogue, and then at 10-minute intervals, you can change whatever interval you'd like. We do it at, what do we do it at now here? We do it at our own center. What are the timing intervals?
Timing intervals for which
for sampling hardware counters?
30 seconds.
Oh, we still do 30. So we do it every 30 seconds here. And then you automatically process and analyze the jobs for whatever metrics you're interested in. You flag the bad jobs. You can notify user support. You can send a message to the user, and then you can have your HPC support specialist work with them. And just the broader impact, like I mentioned, it's being used at academic and industrial HPC centers. It's based on the XDMOD source code, so we have one source code we maintain. It's running at NCAR. Blue Waters is running it, not the performance level stuff yet because it's not available. And that's just some of the academic, and then again some of the known HPC centers. And we don't know everybody that's using it because unless they send us help or something, we don't have a way of knowing. But we know it's a number that's at least 150 or more. And I think that's about, just want to acknowledge everybody, in addition to the people in this room. There's collaborations from the folks at Indiana. They're helping us with cloud metrics, but also they've done scientific impact, which I've not talked about here. And then our friends at Texas and TAC, Jim Brown, Bill Barth, Todd Evans. And then NICS, we have Shaquan working with us. And we thankfully acknowledge the NSF support we've had. So I'm happy to take any questions or...
So, yeah, Roger has another question that I'll read. What is NCAR doing with the storage reporting?
Well, that's...
as far as I know, they're collecting the information, but I'm not sure that they're doing anything with it as of yet. They may be doing something internally.
Yeah, Dave Hart's been doing that for a long time. They actually do internally monitor the storage, and we're in the process for, it's on the horizon, the short-term horizon. We want to add storage to the open XDMOD version.
Yeah, so we'll be able to work with the information you might get out of your quota system to see how many files and how much individual groups are using and looking at that over time. So that hopefully will be in the open source version at some point in the future.
So, Roger says, thank you. There's another question. Can it track GPU utilization?
So the short answer is yes, it can. You have to actually collect the information first. So as part of our work in the Performance Copilot development, we've actually added some GPU tracking support for that. So we do that internally here.
Okay. Other questions?
Gary, I have a question. Is there some way of getting, kind of running this in a sense in batch mode, that is running performance tests and getting something like XML or JSON out so that a gateway could go and collect information and present it in a way almost like Ganglia does or something like that?
Yeah, I'll generalize that question. I'll add that we have another question in the queue. But yeah, how can gateways interact with the information that you guys are providing?
We don't have it's not well published, but we do have a REST service that drives the XDMOD user interface. It's not really set up right now for third-party access, but if it were, you'd be able to query the REST service to actually get to some of the raw data.
Right. So
that would return JSON to you, basically.
Right. So what would it take to convince you to enable such a thing?
Bribery works.
Yeah, bribery works very well.
Big briefcase full of money.
Yeah, there's a fair bit of effort involved in getting that to happen, to be able to authenticate, handle the authentication and everything.
But not to be, all joking aside, we formed two advisory committees. One is a technical advisory committee, and the other is an XDMOD users functionality committee. And part of the role of those two committees are to provide guidance, because we got a long list of things to do that people want us to do, and we can prioritize them, but it's better if the user community helps us prioritize them. So, so first of all, we're working with those committees are just being formed, and I think some of you are aware of that. And we'll be meeting at Supercomputing, the initial kickoff for those. And then another feature we're going to add to the interface itself is we're going to have a tab that is our basically feature tab. What are our current features that are on the horizon, and what the priority is for them, and then people will be able to provide input that, yes, that's a good one, or no, that's not. So, one, you can always you can have a feature request, but two, we'll have committee input on helping us determine what the priorities are, and then three, we want full visibility, so we're going to have a tab that kind of lets our users know what are the things that are on the horizon, and they have a say in terms of what we should make a higher priority or what we should make a lower priority.
All right, Martin Osowski has politely raised his hand.
Yes, I have a question. Is there a way of measuring the total CPU, aggregate CPU, number of CPUs used per application across all users on the system?
Yes.
Yes.
As long as that resource is tracking the applications with TACStat/Exalt or the equivalent.
Okay. Thanks.
Yep.
Scott Hampton posted a question on chat. We run HT Condor on our nodes when idle. Would we be able to configure it to distinguish between that and our normal jobs?
You mean the tax stats or the PCP collector for low-level data?
I'll let Scott.
Hi, this is Scott. I'm just curious if in terms of reporting and usage, those types of things, if we could distinguish, yes, this is a Condor job versus a normally submitted job, and in terms of reports and those types of things.
Yeah, to utilize the scheduler information to know whether or not
we run Condor jobs here, but they use a scheduler, right?
Yeah, what kind of
we
resource
don't run Condor
manager?
jobs here anymore.
No, we used to do something. So you're using Condor right now to sort of backfill around your HPC usage?
Right.
Okay.
Yeah,
we used
to do that.
So yes, just with the current version, you could by exclusion leave out the Condor stuff. But if you wanted to, at some point, you could imagine bringing the Condor stuff back into XDMOD itself. I don't know that we've actually tried that at all.
Yeah, that we haven't tried doing. You'd have to pretty much merge, I think, what your main resource manager and Condor had, so you had a complete picture of everything that was running on a node.
Right. I mean, in terms of the low data and metrics, I mean, that would be sampled anyway, so you're going to get the Condor jobs reported as well, but at the moment, XDMOD wouldn't actually know what to do with those.
Right. It would only report the jobs that were coming in through your main resource manager.
Yeah, but at some point, supporting Condor is not necessarily a bad idea for us, so might be something else to add to our list.
Yeah, Condor is something that can be done. We would just treat it as any resource manager.
Yeah, it's just nobody's asked at this point.
Right.
Yeah, Aaron Hodges has a hand raised.
Hi, do you look at our jobs as well, or is that a little too offbeat, please?
The statistical package are?
Yes, please.
Yeah, absolutely.
Yeah, if it's running on the cluster, then yes.
Yeah, it's one of our
awesome.
Our application names are.
Okay.
I'll add a caveat in terms of the application. So you have to be careful about for the academic centers, if there's commercial codes, some of the licensing agreements, insert Gaussian in there, are very, very restrictive, and so Gaussian will sue you if you report the performance of their code relative to other codes. And so in situations like that for commercial codes, we basically aggregate them all into one area, one proprietary bin, and so that users can't somehow reverse engineer and figure out the performance of. Somebody could go into the XDMOD and reverse engineer and figure out what the performance of Gaussian was relative to some other code and publish that. So for commercial codes, we're very careful and we wall them off.
I have a question. This is Gary. In a way, you can regard this as a client-server situation where you have services running on TAC and SDSC, and you have an application that uses those services. And my question is, how easy would it be to implement those services on a local cluster like we have at UTESCA?
So, I mean, you mean which service are you referring to? Because the answer is probably slightly different depending on which one you're asking about.
Did you hear
well, so I was asking about all of them services where you can go and determine CPU utilization and storage utilization and so on, and access that from a client.
I mean, in terms of XDMOD itself, I think installing it for a local resource is actually not too hard, right? A typical admin can do that in a fairly short amount of time.
Yeah, if you want to install XDMOD, you're looking at about half an hour, then it's installed.
So the heavy lifting piece is probably collecting all the job level performance data. And that requires a fair amount of effort, right? So you need to either install TechStats and start managing the data, and if you have a very large installation, it's managing the accumulation of a fairly significant amount of data. We can certainly help you with that if that's something that you want to do for a resource that's not doing that right now. If you already have an existing monitoring setup, something like Ganglia or something like that, then you're already getting the data, and that again shouldn't be too much additional work.
Right. You'll only be looking at installing the process that would take the raw data, aggregate it into job level data, and then ship that off.
Okay. Thank you.
Other questions? And also we have, go ahead.
I'm logged into XDMOD now and with my Exceed portal account, and I was trying to look up some SDSC numbers, but the Supreme links are grayed out. What would that mean?
Oh, it might be your role in Exceed. Are you listed as an SDSC staff person?
Whole base, so
I don't know.
Yeah, I think if you're just a user, I don't believe that you can get at that low-level data, because then you would see low-level performance data for other users as well. So you would need to be a center director or a center staff member at SDSC.
Okay. How do I get added on? I am SDSC staff.
If you click on the Contact Us form and submit a help request, then we can elevate your status once we verify it.
Great.
So we have a few minutes left if you guys want to do a live demo or anything.
Yes.
And certainly keep asking questions too.
How do I get out of this?
Just want to share the browser.
Yeah, just exit presentation mode and you should see the desktop again.
All right, I'll put that away. Bob, this is your machine, so maybe you just do it. I'm going to have Bob DeLeon take over the keys, because this is his machine, and he uses it more frequently than I do in terms of the XDMOD anyway.
Is there anything in particular that somebody wants to see? Might be the best way to do this quickly.
I would just go through each tab and tell him what it does, and just draw with usage, do a plot or something, I don't know. Can you see his screen?
Yes, we do. Maybe, yeah, one thing to start with also could be just under the usage, you could show the Gateway tab.
I'm not actually sure what information we've got on the gateways here. Let's take a look.
So Bob's doing it quickly there, but you got a menu on the left-hand side that lets you navigate, and you've got all these tabs on the right-hand side. So right now he's in the usage tab, and he's scrolling down. I'm not sure where. There's different realms. So there's jobs data, there's accounts data, there's allocation.
This is basically the data that you have, information you have access to. On the left, in the tree, you have the jobs, which are accounting type data. Then he has allocations type data. Then the Supreme performance data, and then there's also a resource allocations realm, which shows what the allocations are on the various things. But now for the jobs, if we wanted to just look at the job summary, let's see. Yeah, jobs. Where is it? Let's just look at number of jobs, maybe. Number of jobs ended. Okay. All right, it doesn't do that. I'm going to go to the Explorer, Metric Explorer. Jobs ended. Okay. Yeah, right. Now, so if you wanted to look at the number of jobs ended by gateway, for example, you have to go to the Metric Explorer because that's the way to make a more complicated plot. The Usage Explorer, the Usage tab makes very simple plots. The Metric Explorer makes a more complicated ones. This one will be a fairly simple one. I'm going to look at the number of jobs by gateway. Okay, so there's the number of jobs over the various gateways that we've got. There's, I don't know, see how many of them are. And we could look at more detailed, like the number of CPUs that were being used, or so on.
I'm just curious, you guys are submitting lots of jobs as tasks. How are you determining that's a gateway job?
Well, technically, I'm not sure if it's so much a gateway job as it is a community user. Right? So I think all the users end up in here.
Yeah. Okay, these are all community usage, derived from community user accounts.
Yep.
I always, Steve, you know what the reporting is on the gateway usage now. Is Arola gateways consistently reporting everything now, or?
Well, we know that it's a gateway user. We know, as long as we know what user the gateway is running as, or it's a gateway.
Okay.
We don't have access to the individual. We don't know what user on the gateway.
Okay. Yeah, that should be that information should be. We're pushing it now to Exceed Central Database. I'm not sure if it's getting merged, and you may know better than I do if it's not. But we have that information. It may not be merged with the rest of Exceed Central Database, but hopefully it will be soon, so we can see not individual user names, but at least number of unique users per gateway for different time periods.
It depends on what's actually being pushed in. The last time I checked, there were some gateways were reporting that information, but it wasn't anything that was usable by XDMOD. It was like an MD5 hash. So, we would have to either be handled on a gateway by gateway basis, or all gateways would have to conform to the same reporting, so we could do it consistently.
Well, all gateways should be reporting unique users the same way. We could talk about it more later, but I'd love to see that available here too.
Yeah, if we can talk about that a little bit later and find out where it actually goes, see if it's actually there.
Yeah, Dave Hart will need to tell us what to do probably, or Amy.
So if you pick a particular gateway here, you can drill down by different things. I don't have no idea whether this is all going to work. Let's see by job size, for example. Okay. There's that particular gateway and the job size descriptions.
What if you chose field of science?
Let's see.
So that you know that by the code or by the user?
So it'll probably be by the allocation.
By the allocation.
Yeah. Allocation, okay.
Yeah, the field of science actually comes off of the job rather.
No.
Oops.
It can be different all the time.
Here today.
Sometimes just one of those.
Don't you hate it when that happens?
Must be looking at it.
No, I'm only looking at 30 days here.
No.
There's only a few jobs. Oh, you know what? I know Joe is hammering the.
Are you on development?
No, I'm not on development. I don't think this is product.
They run a lot of jobs.
No, we shouldn't. This is unusual. Take this.
something wrong here. Broke it.
You go to the page, right? Below that. Refresh. Well, I'll also add that this is a gateway call, and so everybody is sympathetic to doing to uncovering previously unknown bugs during a demo.
As much as I love to do live demos, I was not planning on doing one. So.
Yeah, well, we appreciate your willingness. Right. Yeah, I'll add too. We're a little bit past the top of the hour, so is there anything else anybody'd like to see, or that you top company you particularly like to show us?
We'd be happy to do a demo. WebEx, we've done that before, and it seems to work pretty well.
Okay.
All right, well, thanks for the opportunity, everybody.
Yeah, thank you.
And Nancy, get it?
Yeah. So one quick thing before we go on, if you could stop sharing and give me back control.
Hey, Nancy, when you have a chance offline, if you can send me about maybe Buffalo hosting one of the XSEED meetings, I'd be interested in that.
All right, you're now in control.
Preferably in the summer.
Yes, it would be in the summer. I wouldn't offer it the other way.
Come on, it's lovely in January.
I'll take your word for it.
That's a pretty good.
Okay. Thanks all.